Section B.2, Running a PostgreSQL Database on DigitalOcean. In most of the book, you've been running PostgreSQL database instances as containers, both in Docker and in your local Kubernetes cluster. In production, we'd like to take advantage of the platform and use a managed PostgreSQL service provided by DigitalOcean, this link. The applications we developed throughout the book are cloud-native and follow the 15-factor methodology. As such, they treat backing services as attached resources that can be swapped without changing anything in the application code. Furthermore, we followed the environment parity principle and used a real PostgreSQL database both for development and testing, and it's the same database we want to use in production. Moving from a PostgreSQL container running in your local environment to a managed service with high availability, scalability, and resilience is a matter of changing the values of a few configuration properties for Spring Boot. How great is that? First, create a new PostgreSQL server named Polar Postgres, as shown in the following code snippet. We'll use PostgreSQL 14, which is the same version we used for development and testing. Remember to replace your underscore region with the geographical region you'd like to use. It should be the same as the region you used for the Kubernetes cluster. In my case, it's AMS3.
See this code.
The database server provisioning will take several minutes. You can verify the installation status with the following command. I have filtered the result for the sake of clarity.
See this code?
When the database is online, your database server is ready. Take note of the database server ID. You'll need it later. To mitigate unnecessary attack vectors, you can configure a firewall so that the PostgreSQL server is only accessible from the Kubernetes cluster created previously. Remember that I asked you to take notes of the resource IDs for PostgreSQL and Kubernetes? Use them in the following command to configure the firewall and secure access to the database server.
See this code.
Next, let's create two databases to be used by catalog service, polardb_catalog, and order service, polardb_order. Remember to replace Postgres_ID with your PostgreSQL resource ID.
See this code?
Finally, let's retrieve the details for connecting to PostgreSQL. Remember to replace Postgres_ID with your PostgreSQL resource ID.
See this code?
Before concluding this section, let's create some secrets in the Kubernetes cluster with the PostgreSQL credentials required by the two applications. In a real-world scenario, we should create dedicated users for the two applications and grant limited privileges. For simplicity, we'll use the admin account for both. First, create a secret for catalog service using the information returned by the previous doctal command.
See this code?
Similarly, create a secret for order service. Pay attention to the slightly different syntax required by Spring Data R2DBC for the URL.
See this code?
That's it for PostgreSQL. In the next section, you'll see how to initialize Redis using DigitalOcean.